Now, let us analyze the complexity of quicksort. Let us consider an array of n elements, as we have discussed that if this is the position of pivot, all elements less than p are in the left and all element greater than pivot will be in the right. Let the position of pivot is such that it will divide this array in such a way, let this position is k, and it divides the array into two parts, where let the first part contains I elements. So, definitely the number of elements in the second part is n minus I minus 1. Okay. So, if I say T n is the running time for quicksort algorithms, then how we can express T n? T n is the running time to partition and then followed by running time to call quicksort for the first part, where there is I number of elements. So, running time for quicksort for this first part is T I, and running time for quicksort for the second part is T n minus I minus 1, and running time for the partition process, where there are n number of comparisons, because every element is compared with the initially selected pivot elements, that requires n number of comparisons. So, that requires C n time. So, we can represent the recurrence relations for quicksort by this relation. So, this is the time to perform quicksort with n elements. This is the time for quicksort for the first part, this is the time to quicksort for the second part, and this is the time for the partition process, that is the divide process. Now, consider there are various cases are possible, because as we have said earlier, that is any pivot will work. In the earlier examples, we have considered the first element as pivot, but any pivot will work. Now, there are different possible cases. Let us consider the case 1, where the pivot element is such that every time all elements will be in one part and the other part will not contain any element, that is either I is equal to 0 or n minus I minus 1 is equal to 0. So, if I is equal to 0, then this recurrence can be written as T n minus 1 plus C n. So, when this will occur? Suppose your array is sorted, suppose you have a sorted array and you have considered that the first element as pivot. So, if this is considered as pivot, so then naturally every time what happens, the first element, if the first element is pivot, then there will be no element to the left of this pivot, all n minus 1 elements will be in the right side. So, that will be the case in all successive recursive calls. So, if we telescope on this recurrence, so then this will be again T n minus 2 plus C into n minus 1 plus C n. So, in this way it will continue. So, if we telescope this, then we will have C, we will have C of this is 1 plus 2 plus dot dot plus n. So, this is nothing but order of n square, because this series is nothing but C into n divided by 2, okay, from 1 to n. So, this is n into n plus 1 by 2. So, this is order of n square. So, in this case quicksort is as bad as bubble sort. So, this is worst case. Okay. Now, consider another case where the pivot element is such that it will divide the array into two equal parts every times. So, in that case I is roughly n by 2, either ceiling value or full value, I am ignoring that. So, I is equal to n by 2, that is the partitioning element is chosen in such a way it will divide the array into two equal parts. So, this recurrence can be written as T n is equal to T n by 2 T n by 2 plus roughly this is also n by 2, roughly n by 2 plus C n. So, this is nothing but 2 T n by 2 plus C n. So, this is an well known recurrence that we have solved in merge sort, and if we solve it, it will be big O n log n base 2. So, that is the best case. Now, when this case will occur? If your input array is sorted array and if you select the median element, that is median element as pivot element, that is array is sorted, input array is sorted, and we have considered median element as pivot. So, in this case every time the median element will divide the array into two equal parts. So, every times that will be divided into two equal parts, next it will be n by 4 and so on. So, we will get the best case. So, now we understood that selection of pivot plays a very important role. The same input array, sorted array, if we consider the first element as pivot, that will give the worst running time order of n square, and in the same input if we consider the median element as the pivot element, that will give you the best running time order of n log n base 2. So, pivot selection plays a very important role. Next, let us consider which is more probable, that is the average case.